to know more about civil engineering, and we would like to perform better in exams. So I found them very like helpful and very enthusiastic. And all the students, it's my great pleasure to introduce Dr. Sadik Khan here. So I really appreciate that he joined us today, and he gave us a valuable time. I just to formally introduce him. Actually, I already shared his profile with you. Again, I just want to give some small things about him. So, Dr. Khan, actually, he's a BUET alumni. So he graduated from BUET in 2007. Then he did his PhD from University of Texas at Arlington. Also, he did his master's also from there. And his in the interesting thing is his supervisor and my supervisor is basically the same. So when he graduated, after his graduation, he also did a postdoc for a few years, and then he joined Jackson State University as a tenure track assistant professor, and now he is working as an associate professor there. So he has a lot of experience in geotechnical engineering, in civil engineering, sustainability, and transportation, geotechnics, numerical modeling, so a lot of things. So he has a lot of funds from Mississippi DOT. Also, he had some previous funds from Texas DOT. He is working with U.S. Army Corps of Engineers. Actually, they have one in research and development center, RDEC. So he has many funds from there. And the most important thing is he won the NSF Career Award. So it's a very prestigious award. So probably you don't know about this, but when you go to the USA in future, you will know about this. How much it's difficult to get this award. So again, thank you, Dr. Sadiq Khan, for giving us the time. And yeah, the floor is now yours.
Thank you, Dr. Islam. I appreciate that. So, guys, I cannot see you, any one of you. So, if I cannot see you, it means you are not listening. And in that case, it's kind of like a one-way journey. One-way journey, I don't like that. So, if that is possible, you can open up your camera. I can see your face. Otherwise, I don't know whom I'm talking to. I just see the numbers here. Two is all two.
Yeah, please, guys, can you please, if you don't have any problems, can you please like turn on your cameras so that like Dr. Khan, I can see your face.
Okay, good. Looks good. Okay, if you're uncomfortable about your background, you can blur it. For me, it's also the same. So I'm in my attic, which is it's kind of like a gym for me. So, but you can always blur your background, so it really doesn't matter like where you are. Uh, anyway, so I have done few works with the LiDAR and drones, and basically I wanted to talk about it, but kind of like a big picture of what is the application of the LiDAR and drone. And before that, let me ask some questions to you guys. And usually this is how I like to teach. So, how many of you have seen a LiDAR device? Anyone?
No, sir, we
How
haven't
many?
seen.
You haven't seen. How many of you just heard the word LiDAR?
No, so this is the first time I'm hearing about
Okay,
it.
this is the first time you're hearing about it. It's a device. Uh-huh. Yeah, it's basically LiDAR just use the laser, and it shoot the laser. And yeah, it's a light. Yeah, yeah, laser definitely a light. Yeah, just a specific wavelength. Mm-hmm. 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 Okay, awesome. The LiDAR, I'm trying to see if I there is any photos of LiDAR drones. Maybe one. Okay, so let me try to share my screen first. I think, Dr. Islam, you need to give me the permission to share this screen. It shows the
Uh,
only meeting organizer and presenter can share. So
let,
maybe you
let,
can just make
let
me
me
a
check. Yeah,
presenter. Yeah.
right. Let me check. Oh, settings. Options. Okay, Dr. Khan, can you please try now?
Yes, I can share. Great. Thanks. Okay, guys, so I'm just sharing my screen here. And basically, I have done a project with Mississippi DOT, and I'm just showing you some of the results from there. So I believe it's going to be very useful for you. And so in this case, we use the LiDAR drone and some other techniques like ERI, resistivity, and even the GPR here. And I saw the syllabus, and the syllabus, your syllabus also covers that. But I'm kind of like I'm not going to talk about the ERI because I haven't seen the ERI is a part of the coursework. But uh, basically, I'll try to give you some example of using how glider and drone can be used, and what are the major application and what we see from there. You know, so basically, the question I was asking to you is like, what is a LiDAR and how does LiDAR looks like? So this is one of the device that we are using. I Let me try to make it full screen so I can use my laser pointer here. You can see my pointer, right? So
Okay.
in terms of the LiDAR, so that again, the question I was asking is how many of you have seen the LiDAR, or like what it does? How many of you have seen the total station?
So we have seen it in our class.
We all have seen
The total station, right? And you have seen the level, right? And you know, like what is the basic steps of doing a topographical survey? So
We didn't know how to use it, but we have seen the device, but we don't know how to use it.
okay, so but have you seen the total station, the use of the total station, or not? Not yet. Okay. So in terms of the total station, what happens is like you have a device. So let's say here is one device, you know, and then you have another one. Let's say this is a reflector, you know, and from the total station, you are again trying to like shoot a laser or light, whatever the way you're gonna say it, and it get reflected from the reflector, which is a prism, you know. So, and in terms of the total station, you can go like as long as the light can travel and you can see it, you know. So it has to be visible, and there is no limit on that. It can be a 1 kilometer, it can be like 500 meters or so, and you get the data. So from one point you can get like you can shoot at different points and you can get like xyz. Basically the objective of creating the surveying or getting the points is to create a like a contour map, right? How many of you know what is contour? Do you know what is contour? Have you seen contour?
So we have learned a little
Yes,
bit
sir.
about contour map, but we
Okay,
haven't
so
seen
what you
the
have
contour
learned?
map yet. Uh, it's almost, sorry sir,
It's
I'm
almost.
unable to
Simply
So,
define it.
Dr. Khan, the interesting thing is the
You
contour
to
topic has not been covered yet. So
Okay, no,
probably,
it's not a problem. It's like the
yeah.
things that I'm trying to give them is like I'm just trying to create a background on them. So if they don't know, it's fine. I'll tell them whatever it is. I'm just trying to know is like what is their understanding. So yes. So in terms of the contour map, okay. So the contour map or any other thing, forget everything. So let's say we wanted to create a digital representation of our current situation of like so we want to build something. Let's say we want to build a roadways, you know. So to build a roadways, first of all, we need to know is like what should be the layout of it. If there is a like a hill, if there is a pond, if there is like a water body, if there is something, you know. So and then we want it to be represented in the drawing. So to do that, the basic idea is like we need to get the points like XYZ points at different locations, you know. So total illustration has been used as a like a very advanced method, you know, and it's been there for like maybe 20 years, 25 years like that. It's not a very old technology. Before that, people used to use the theodolite. So theodolite is like, you know, like most of the seniors from BUET have used the theodolite. So theodolite is like you just have a level, you just placed it, you have like a level rod and you have to shoot and you need to see like what is the level there and then you have to manually target each of the points, you know, in a distributed scale. So the total station is something that is super advanced, and then people started using the LiDAR. So the LiDAR has been, but before the LiDAR, there is another thing, which is the drones. So in terms of the LiDARs, what happens is like LiDAR shoot the laser beams and it can shoot like 1 million points per second or 3 million points per second. So when it happens is like it has a scanner, it can shoot the laser beam. And then when it shoot it, it also get reflected. So you don't need a reflector, you know, it can just collect the data as you are using it. So you can just transmit all the laser beams. The laser beams goes around. It gets reflected with whatever the things you have, and it collected the data, and all the data is being stored. But again, it is not very accurate in terms of like when the reflection signals are weak. So we need to have like a certain proximity within that. If it is shooting the laser beams, the it has to be reflected and being captured. So most of the cases, most of the non-destructive testing or the remote sensing toolbox has a similar philosophy. Like the same way the radar wave or the radar in Bangladesh, people call it radar. So how the radar works? Do you know how the radar works? Army use the radar, Navy use the radar, right? All the Air Force use the radar. So how does the radar works too? Any idea? And it
Maybe
exactly.
using some maybe using some kind of different kind of wavelengths as a signal, and then
You
like
need to have a lag. Yeah, time lag. So
sorry sir.
yeah, it's like when you are using the different waves, you also need to create a time lag. So, like
Yes sir.
if you get only one reflection, you get 1 point. But if you create like multiple waves at different time frames, so you have like a from the same source, you're getting like different waves with a lag in it. So you can create a profile in that case, you know,
Mhm.
because you can track it now. So in terms of the LiDAR, it does the similar things, but it just shoot only one wave. It doesn't shoot multiple type of waves. and it creates the 3D of it. That's the overall basics, you know. And then the say
Sir, can LiDAR calculate the area and volume around us?
everything, everything. LiDAR
Everything.
can calculate everything.
A total station cannot. Total station is
Total
just for
station
one
is very
dimensional
manual.
measurement.
Yes, total
Yes,
station
sir.
is only 1 point. So what you have to do is like so from 1 point you have to go, you have to walk around it, you know. But from the LiDAR you just go over the area, and then you can collect all the data. So now the total station is like the way total station works is just it's a terrestrial method, right? So you just put it on top of a tripod, and from the tripod you are collecting the data. In the LiDAR, what you can do is like you can do it in terms of the similar way. You can just put it on top of a tripod, and then you can collect the data, which is the terrestrial uh, LiDAR method, or you can also do it in terms of uh, like you can put it on top of a drone or a like a aircraft. So now drones are very cheap and drone are very popular. People can use the drone in most of the cases. So you can use the drones and lidars together, and then you can just fly on top of a certain area, and you can get all sort of the point cloud. All you have to do is like you just need to set up your flight that is flying like 100 feet, 200 feet level, and is not being stuck with any kind of object. So you just need to set a height, and then you can fly on top of the area, and then you can collect the image, you can collect the LiDAR, like the point cloud, and you can also collect any other sort of things. Like in terms of the drone, you can use different type of the sensors, and there are thermal sensors, there are like hyperspectral sensors, all different type of the camera that you can use. And when you're using different type of the camera, then all sort of camera has like some kind of signal processing things. So you're getting the signals. Now we need to process the signals to make a decisions after here, right? So I wanted to give you some examples, but before that, I want to just give you some very um, broader understanding of like how does the things works. Do you have any questions so far? You can
Yes,
stop me
sir.
at any time. Yes.
Yes, sir. Sir, what happens if the ray didn't come back? It is absorbed rather than reflected. What will happen
If
then?
it is not being absorbed, it's missing, it's gone. It has to be reflected.
Every time it's reflected from
Yeah.
any
It's
object
like
around
there
us.
is always some noise. It's a very good question. It's like whenever you're shooting, it's some of the point is being reflected and is gone, right? But at the same time, the LiDAR has a very high accuracy, because what happens there is like you're just shooting it, and then you get to the point. Then you're shooting another set of ray and you're getting it. It's not like there is a lag in terms of the millisecond, microsecond. So it's not like you're continuously shooting it. You're just shooting it one time. It's like a camera, right? You're just like one sort of image. So to take the image, you are shooting all the LiDAR wave, the laser wave. You get a reflection. Then you shoot again, you get a reflection. You shoot again, get a reflection, like that. So the device that we have, and we have been using like over the last 10 years, is this one. This is called the Trimble X7. So the Trimble X7 is being used to collect the data, and this is where we are kind of using the methodology. Like we are using it on top of the highway slopes to understand like how the failure happened, and to create like a digital image of the failure, and then we can do some kind of analysis and find out like what is the utilization of these things. So basically for that LiDAR survey, what we have to do is we need to do a 3D LiDAR scanning data collection, which should like 3 to 6 million of data points per station, per, you know, and every time when we are shooting it. So the way it works is like we need to have that LiDAR device at multiple locations. So if you want to create an image like that, what we have to do is like we need to place it at different points at different time. And basically, it's going to take like 35 to 40 minutes to collect the data for a slope looks like this in this area. And then, so we need to have it calls the multiple point cloud registration, which is like we need to place it at different locations 6 to 8 times. And we want to have like some kind of overlap on in terms of the previous data. So let's say we are, I draw, yes. Mhm. It's a 3D, I'm showing that. It's a 3D data. Yeah, it's a 3D data. It's all direction. It's a shooting. It's a 360-degree camera. You know, so it's a 360-degree camera. It is you see the it's a circle, right? So this circle usually rotate. When we start getting the data, it started rotating, and it's shooting the data. So in it has like two sensors. One is the laser, the transmitter, and the one is the receiver. So basically, the receiver is the one which is getting all the difference. And now it knows like is the trigger point when it shoot all the sensor, all the data, right? And then it also has the receiver. So from the receiver and it just look at like the time difference between the different points. So you are shooting the laser, which is light, which has a fixed velocity, right? So you know the velocity, you know like how much points you're shooting, and then based on the reflection, you know that there is a time difference. So based on the time difference, it just calculate a reflection point. It rotates on the vertical axis, but not on the horizontal axis. No, it also rotates on the horizontal axis. I'm wrong. Yeah, it rotates both vertical and horizontal axis. So it's a once we shoot it, it rotate like this. One by one, it started rotating, and then on the horizontal side, it also rotates like that. You know. So is the this is the terrestrial, yeah, to cover the range. But in this area, is kind of like if we are shooting it here, like place it at the middle of that area. What it's gonna do is like it's gonna get like a around 10 meter or 15 meter area. It create a point cloud profile. But we are not getting the whole thing. This is like a almost 500 meter by maybe how what is the height? Maybe 100 meter. That's the area we have the point cloud. You know, so now that 500 meter by 100 meter area, if you wanna get that, then what you have to do is like now from one point. So let me try to have the pen. So let's say I have a point here. Now I'm getting a area of data here. The next point I should try to have somewhere here. So what it will do is like it will have another set of data here, you know, and then we need to have like another point. So we are replacing it at different points, and within that point, it is getting a certain amount of point cloud. So when we are getting that point cloud, we also need to make sure that there is an overlap of like 20% or 30% data with the previous one. So it do a very well registration. So that's why it called the multiple points point cloud registration. So the registration system works like when it kind of stitching with the previous data set. So from the previous data set, it can connect, and it's an automatic process. So the built-in software inside the device do it automatically. We can use the data on many things. We can directly take it to the CAD. If you want it to on the GIS, you can do it on the GIS, but the best idea is to do it on the CAD. So we use the Civil 3D, and in terms of the using it on the Civil 3D, we need to do like multiple steps of the data processing. But finally, we get all the point cloud data in the Civil 3D, and then in the Civil 3D, we can create the contour, we can create the surface, we can do whatever the things we want to do. You know. hmm hmm the plane. Well, in terms of that yes, technically it will you'll if you're flying from the bottom of the plane, you'll just see some part of it from the top. You'll see that. But what happens is like most of the cases the softwares they can eliminate those and take it as a noise. So if you want to collect that, then you then, yeah, it says like right here you can see that there are people, you know. Yeah, the software and you
Sir,
can do that. It's like you can also eliminate those. You can also remove many things. Like we can say there are trees. It's
sir, can Civil 3D remove the overlapping data? Muted.
Dr. Khan, I think you are muted.
can you hear me?
Yes, now we can hear.
Okay, sorry, I don't know how I got muted. Sorry. So how far you are? Is this like yeah, we can see the person, we can see anything. It's just like as long as it's there being captured, we can see it. And after that, we can take everything on the software. So the device that we are using called the Trimble X7, uh, the device cost is $75,000. So it will be close to 1 crore. Uh, and so it's on this one, but it also comes with the software and hardware and all sort of like the data collection device. It's a full package. But I got it in an like discounted price, so I need to spend like 40K. So in total, it's like 50. It still is 50 lakh taka. And then in terms of the software analysis, what we can do is like we can also take off all sort of like the noise or noisy data. Even we can also take off like all the trees. So in interestingly, what happens there is like you can select all type of the image, and it's like a small point in the CAD. So if you just open up in the CAD and create it as a point cloud, you can also manually delete those points, and it's there. It works. You know, it's really interesting. It takes very long time to do that data processing. But if you want to create a really good data, collecting the data is like few hours, but to do the data analysis takes like a day. You know, and you also need a super high computational power in terms of the computer, super high. The insurance we can, but we're a university. As a university, if something happens, uh, the university that doesn't pay, so we can usually try to send it to others. For this one, usually insurance is not needed because the students who are working with that, they're very careful. But sometimes what happens is like if we have the LiDAR on the drone or just the drone with the camera, you know, it may have like some issues. So we recently bought like the LiDAR on the drone, and it's like uh, that's the most advanced one. So we are not using the Streamwell one anymore. We just use it like under some cases under the bridge or something. So let me show you like some of the example. I think I should be able to show you that. Where is it? Laser pointer. So it's like a typical LiDAR setup. So you have to have like at different points, and we're moving it, and then it here you can also see it's like there are some things is sticking up, and it's a white things. It's like a bulb. Can you see it here? It's like different points, right? So
जी
what
सर.
happens is like it's if it's an open surface, and then it doesn't have like very specific points or objects to register for the registration. So in this case, like they cannot do a good overlap, you know. So what is needed is like we need to have like multiple objects we need to set up at the field, and then it use it as a reference point. So using it as a reference point, it can collect the data, and all the data being merged together to create it at the interpoint cloud. So this is how it looks like for a bridge, for a 3D. And I also ask you like if you have seen uh, like what is contour map, right? So the contour is like something you are looking at a slope or a highway or a bridge, and you can see it as like a different type of the grades. Usually horizontal or vertical grades are the combination of the point cloud, but this is how basically looks like. And this is one which is like on a highway slope and a with the trees. You can also see like if I zoom in, these are the points, like all sort of like the the point cloud. So every point cloud is here. uh, and then this is another one, is like this is a slope, and but this is from the drone. Now in terms of the drone, let me just move forward very quickly. Yes. So in terms of the drone, what happens is like we wanted to get a 3D image from the drone. So how does drone works? How many of you played with the drones? How many of you have a drone? Photograph, like just for the simple photography. No one have a drone?
Sir, out of
Yes, it's
budget.
fine. But I
Sir,
saw in
it's
Bangladesh many
really
people has
impossible
the
for to have
drone.
a drone, sir, for a
But
Bangladeshi
how about the
student.
small one? No, not the expensive one, but the small drones. Like for the yeah, it's like you can buy those drones too. It's like they're like really say it again. No, it's okay. In terms of the drones, what happens is, let's say we wanted to get a image of an area, and so we want to do the survey. So basically, the purpose of the survey is like we want to collect the data, and we wanted to get. To me, is like all we is needed is if we can get the XYZ of the entire surface, and if we can create XYZ, uh, that's the we can do all the sort of calculation like area volume calculation. We can create the DEM, which is the digital elevation map. We can also create the DSM, which is known as the digital surface map. So the DSM is like a 2D, DEM is a 3D. you know and so in terms of the drone imaging, what happens is like we it just basically use the concept of the photogrammetry. So Dr. Islam, have you covered the photogrammetry in the class?
Yes, it has been covered already. Yeah.
Okay, so in that case, they should know about the idea of the photogrammetry, as is like
Yeah.
in the photogrammetry, you are just getting the image and you are looking into it from a certain points, right? From the angle. So all the camera image comes with a angular calculation. So that can be merged together. So let's say if you're zooming in or zooming out, the perspective of any image has changed, right? So it also has the data there. So if we are collecting, let's say we have a, see me, I cannot see myself, so I don't know. It's like how it works, but you can see me, my hand, right? So let's say Let me take my phone. So let's say I want to take an image of this surface, and I'm taking image from here, from here, from here, from here. It's like different points, right? So when I'm taking image from here, it can take a area, it cover a certain area, right? When my image is here, like my camera is here, I can take a certain portion from the other side. So I'm having some kind of overlap, but I'm looking into it as I'm flying on top of it and taking the image from a different angle. I can now connect it together and recreate the image, right? And it has like a certain portion of the overlap. So basically, what happens here is again, let me try to have the pen. So let's say we are trying to have a photo. So usually what happens is like in terms of the photos, we have like many photos here, and that has been collected as a grid at different points. Sorry for I'm just using my hand, so it's not very it's not very accurate, but please ignore that.
Sir, can we
So
zoom this image?
yeah, we can. I'm going there. I'm just trying to give you like an overall understanding of like how it's being created, you know. So the way it works is in this image, let's say there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 30 image in this one. I think in this one, in reality, we have like more than 1,000 image for this one, you know. So the way it works is like, first of all, we need to get a drone, set it up, and then the drone uh, kind of break it down into a certain grid. And then in terms of the grid, we need to define like each of the points. And then the software define like which are the points it's going to collect the data, you know. So if we want to collect it very fine, our travel time will go up, you know. But let's say in this case, each of the point we wanted to get the data, you know. So what it will do is like that we set up the drone, the drone will go up with the camera, and then it will take the image from each of the point, you know. So when it's getting the image from this point, let's say it's collecting the image of the entire area, right? That's the first one. Then the drone will stop here at the next point, and it will get the image of the entire area. Looks like this. All right. So between these two image, it has a overlap. That's the overlap it has. But when it's collecting the data from the second point, the angles of a certain point is looking at from the different perspectives. So from one perspective, from this point, let's say I'm looking into a certain object. I'm looking from here. I'm looking from here, right? So I'm looking from two sides. So there is the angular distance, right? So from that angular distance, then the software will merge it together and it recreated the surface. But when I'm looking into it from different points, I can look and I can see it as a 3D image, right? Because I'm looking into it from different side. So if there is a difference, we can also track that from the angular measurements. You get the point from it, that's the overall idea of the photogrammetry is like whenever you are looking into it from different perspective, the angular calculation you can merge it together and then you can recreate the whole image.
Sir, does elevation calculation helps here to identify the which place is actually overlapped area?
In terms of the overlap, we don't need to see that. Overlap is just being calculated for the quality of the data. You know, if we don't have a like a good overlap, then your quality of the data is going to be poor, and in that case, you won't get a very nice contour, you know, or the 3D image of that. So usually, what happens is like we want to have like almost 30 to 40% of the overlap to get a good data, you know. But at the same time, it's like if you're flying the drone your travel time will be much higher if you want to get like many points, you know. So if a area looks like this is a interstate highway, and this is an exit, and on this one we have a highway embankment and slopes that we are monitoring. So for that one, we can set up our grid in different ways, but whatever the grid we are setting it up, our major target point is right here. I'm not showing it here, but you can see it like from this side. So now if we want to zoom in, it's you can see the details. Mhm. Uh-huh. Multiple positions, multiple positions, like two positions is just for one, you know. Mhm. Yes, yes. You need to have the overlaps because now the calculation has been done in the software. You don't know you need to do it, but you need to understand it, how it works. But the way we are using is like we have multiple softwares. Well, the right now the software we use, it name is Pix 4D. So the Pix 4D is a very well-known image processing software, and from there we can have like multiple image, maybe 250 to 300 image, it is stitched together to create a map looks like this, you know. But when we are have a very good overlap, you can zoom in, and basically you can see is like if there is any crack or anything happens here, you know. It can be seen like very easily. It's like, and if you have this image multiple times at different season, you can also look into it in terms of the changes. But at the same time, this is the elevation map. So in terms of the elevation map, it can also track down like if there is any hole, if there is any kind of depression on the ground, and so on, you know. So you can also look into it is like, is this the curve, and the height of the curve is like 4 inch on the road. So it also, you can see the curve, you know, this is the curve line, and it's being presented as a 2D, but in the software you can see it as a 3D. So you can also rotate it at from different points, and you can also target it like, okay, so this is basically the 3D of the whole thing. Now, if you have the drone, that's I call it the drone is your starting point, because from the drone you can just look into the entire thing, and then you can target like, so this is the area, maybe a certain area has to be a certain area has a, you wanted to see it. Oh, if I zoom in, that doesn't let me have the laser pointer. So let's say you wanted to get a certain point, certain area here, and then on that area we want to do the LiDAR. Then we bring the LiDAR and we easily do that, you know. So that way is more efficient, time and cost efficient too, because you don't need to spend like so much computational time to get to the entire thing, and you are also getting some sort of data that is not needed. So in this study, what we did is like we tried to identify the critical locations within the slopes. And then once we identified those critical locations, we wanted to do the instrumentation and monitoring. So for example, we knew is like on that slopes, there are like certain areas where the slopes are moving. And then we identified it from the LiDAR and drones. And once we identified it from the LiDAR and drones, then we kind of collected the data using some other methods like ERI. We also have like the instrumentation, and through the instrumentation, we are also looking into it like how things are moving. So on the same area, we also had like a inclinometer, and we are monitoring the movement of that slopes. So we are seeing it like at different points, the slopes are moving. So you can see it like at different time, the slopes are moving from one point to another. So we can also identify the failure depth and all sort of things here, you know. So we can identify like where the movement is there, but this can be done with the LiDAR too. So for example, what we are doing with the LiDAR is we are getting the data from different points, and I think this has been done with the LiDAR. Yeah, this is the LiDAR image. So that's what I was saying. Like from the drone, we are getting a certain points, right? And from that points, we also trying to identify like what are the major changes on that point. So what we need to do is like we can create a image from the drone. So this is how it looks like from the drone image. And if I look into the surface profile, you can see it's like it shows some changes, but it's not super accurate. You know, it has like the accuracy level is close to an inch using the drone image. And then if you wanna use it more accurately, then we can look into it as a LiDAR image. And from the LiDAR image, basically we can look into every sort of details, you know. And from that, yes, is the drone. Well, the LiDAR and drones are two different methods of collecting the data, right? And then you, when you do that, the analysis, you also get two set of data. One is the image and one is the point cloud. So if you're using the image, you get one set of the profile. If you're using the LiDAR, then you are getting the another set of profile. You can merge it together. You can use it separately. It's up to you. It's up to us, like how we're gonna do that. Uh, it's like if we are using the LiDAR with the drone. In this case, the data has been collected is separate. It's a separate data collection. So the drone has been flown on top of the slopes. And by the way, it's a you can see it's like there is a yellow line, and that yellow line was like we are doing the resistivity imaging. So for that one, we just set up a tape, and is also visible. So how accurate that data is, you can see that, you know. So you just collect the data in two separate ways, drone image separately, LiDAR separately, and then we merge it together in the software. And then we also have like a thermal imaging. So we also use the thermal imaging to capture how does it looks like. So so these are thermal data. So in terms of the thermal data, you can see like the temperature here, you know, and some of the areas the temperature is like super cold. Some of the areas the temperature is high and is within there. Now, what happens there is, do you know what changes? What can make the changes between the soil and within the same soil? How we can have like so much variations in terms of the temperature? Oh, sunshade. Okay, sunshade is one. Other than sunshade, is like the way it is visible is like there is not much sunshade here. But other than that, there might be something else we don't know. Any idea?
Sir, for the road,
Yeah, it's just like this is the one. This is the road. This is it's a bridge. So on that side, you can see my cursor, right?
yes, sir.
Can you? Okay.
Yes, sir.
So
Sir, is it due to the
here is the
grass?
road. Okay, let me use the laser pointer again. So here is the road. This is the bridge abutment, and then this is the abutment slope. Uh, and this is the bridge, and is on top of it is a I think this is the abutment slab, like bridge approach slab, and then that's the pavement, you know. So which means this is concrete, it's a riprap, and then here's the soil, and then there's a pavement, you know. And what we can see here is like this area is under the shade, right? So the temperature is very low here, which makes sense. So the temperature is super low. Then it's there. The area is concrete and has been exposed to the sun, so it absorbs the heat, and the temperature goes up, right? Right here. Uh, the next one is this is also the concrete, and this area has a higher, like is quite cold right here. And I think on that day, the day data has been collected, it was very cold. We can also see the difference between these two is like whenever there is is like a joint, right? So we can see the joint very clearly. So we can also see the joint here. So two joints right here can we can see that very clearly. And then within the soil, if you look at the soil, what we are also seeing is like some part of the soil is super cold and some part is not. So what part of the soil can be super cold versus the other is not? And do you know why?
Is it due to
What
the
makes
grass?
that? It's due to the grass and there is another thing. Is the moisture. No. It's not to the it's not the level. Basically, what it has is like it has like the moisture, the amount of the moisture. Water has a different like it's the heat absorption rate, right? Soil and water has a different level of the heat. Is the Latin fusion? What is that term? J, a or
Latent
K?
heat constant.
Latent heat constant. Yes. So for the soil and water, your heat constant is different, right? So because of that, you will see the difference in it. And targeting the thermal image, we can also identify the moisture, wherever the moisture is. Like the trapped moisture within the soil can be identified very easily.
Sir, is that
Yes.
means in forest area the soil will be really cold?
It depends. In the forest area, you will have the canopy. So because of the canopy, your soil temperature is different. But it's a very good question. Let me show you some data that we also have in terms of the soil moisture or the soil temperature. So this is the air temperature, on the back. All the changes we are seeing is the temperature, and then in terms of these data are the soil temperature at different depth, like 1.5 meter, 3 meter, and 5 meter. You know, so the 1.5 meter is here. The 3 meter is we are seeing some change, and then there is a 5 meter which is not changing that much. You know, so and this is a really interesting data because you can see is like that 1.5 meter depth. The soil temperature variation is very similar to the variation in the air temperature, right? But if you're looking into the 3 meter, we are not seeing the changes. There is a lag, right? It's not changing much. So the heat transfer mechanism within the soil is different. It's even though it's the heat transfer is a very popular topic in the mechanical engineering. In the civil engineering, people are not using that very much. But it's a very good data for the geothermal energy calculation. So for the geothermal energy, what is needed is like if you go deeper and at a certain point you can see is like there is no effect of the cold temperature. So the it's kind of like the soil has a very constant temperature there. So if you can harvest that energy from the soil, then you can also save like a lot of energy, and that's another source of the energy. So there are many people who are also trying to work on the geothermal energy, and in terms of that, if we have this data, we can also use it very effectively. But you can see
Sir,
that like the changes is very prominent. Yes.
sir, geothermal energy is a topic of mechanical engineering.
No, heat transfer is the topic of mechanical engineering.
Oh, so geothermal energy, getting energy from the
Geothermal energy
soil.
yeah, of the soil is like it's a part of the geotech now. Many researchers in geotech they started working on the geothermal energy because it has lots of fun.
Yes, sir, it's really
But I'm
popular.
not working on that. It's not my topic. I have like several topics, but it's like there are some limitation. I cannot do everything, right? But it's like some of you can pick this topic as your thesis in Bangladesh. I don't think anyone did any work in Bangladesh on the geothermal energy. So whatever the work you're gonna do is gonna be niche, you know. And you
Sir,
can try
how
that,
how
especially
we can collect data from Bangladesh? No, nobody is going to support us.
why not?
Sir,
I
there is
don't
no
think that's a
system here.
problem, honestly speaking. I really don't think that's a problem. Everyone will support you if you want to do it. It's like first you need to believe you want to do it. You wanted to do it. If you wanted to do it, how much money is needed? It's not much. In Bangladesh, it's like is you whatever the money is needed to do it here. I think it can be done like in 10% cost in Bangladesh, honestly speaking. So why not?
Yes, sir.
No, it's not for the cheap labor. Honestly, it's not. It's like the way the culture works in Bangladesh is cheap. It's not for the cheap labor. It's not right. But the labor in Bangladesh is not cheap. Is now that the cost is quite similar to what we have in US. At least for the qualified people. Cheap labor is like for the unqualified people. For the qualified people, the labor is not cheap. It's not cheap anywhere in the world. But it's because the way the system is being designed, Bangladesh is cheaper. Because in terms of the margin is low, Bangladesh usually no one try to make a very big profit, and also it's like you can find like very it is. I feel like in Bangladesh there are people who are really good. The only problem is people don't know they're good. No, it's a more of a mindset issue. It's not a communication issue.
So we don't think big.
We are not being used properly. If you compare it with India, go ahead.
Yes, sir.
Like if you wanna compare it with India, the students who are coming from India, they are like very much well prepared, And in terms of that, they're also very, very well trained in terms of their mindset. I believe in our education system there are some gap, and we always try to promote it in that way. Everyone is being taught to play safe. We need to get out of the safety and the comfort zone and then do something like something different, and then you can do that. So that's a different lecture. It's like it's not a part of it, so we can uh, if you want to talk we can talk about it later. But in terms of the geothermal energy, if you want to do that, all you need is the thermal sensor. You need to have the drilling. So if you want to do a drilling, it takes like only maybe uh, 1 to 2 lakhs to do a very deep drilling. I think the drilling cost in Bangladesh is like 30,000 taka. So for a one single drill. So if you wanna collect the data, if you need only 1 lakhs for the drilling, you need to have the sensors, the thermal sensors. The thermal sensors need to be placed at different points. So in total, that doesn't need more than 10 lakhs. That's nothing. And you just need 10 lakhs, you can place it at different points. You can do it in the civil engineering building around the corner of the civil engineering building, and then you can collect the data, and you can get once you get the data, then you can also there are a few other models. What you can do is like in terms of the heat transfer models, you can do it in Plexus and some other softwares that allows the geothermal modeling, and then you can build some models in terms of like how you are getting the data and what are the things that you can do out of it. You know.
Sir,
So yeah, go ahead.
sir, yeah, I have a question in my mind that how can we actually calculate or get the thermal data from a picture?
Thermal data from the picture. Okay, so thermal data from the picture is like the one we are getting it here is uh, it's a sensitivity analysis. You need to do it in terms of what is that? I think right here. Yeah. So it's a for the thermal energy, you all you have to do is like you have to go back from the basic physics, and you need to have the sensor. The sensor will have like have you seen the movie where the armies are using some other goggles, you know and they can see is like the heat map. So if there is someone in a building, is like they can see the movement. Have you
Yes,
seen
I
that
played
in
a
movies?
game, Call of Duty. There I have seen it.
Right. So how you can do that? Like, what are the philosophy of that?
So maybe they use infrared lights.
Okay, so they use the infrared lights, and then that's a different band. Light has like and plot it and get the data, right? So it's just like when yeah, and the way it works is like the light has like different band, you know. So and it's a wave, and it has like different band of the wave. The most of the cases, the camera that we are using, it has the RGB. So it's just the visible light that we are using. But there are other band of the lights. So if we use the camera that can also track down those wavelengths, then we can also break it down in multiple ways. So for example, what we did is we bought a hyperspectral camera, is like last month, and then we are mounting on top of the drone. Now the hyperspectral camera.
So
Dr. Khan, I
you
think you're muted again. Uh, yeah, no,
Is good.
yeah, no, yeah. Now we can hear. Yeah.
Okay, interesting. So uh, the way we are using it is we are using the red, green, and blue. So that's the RGB sensor we are using, and all the data we are getting is in terms of the RGB. Now we are buying the new sensors, which which is also using, it's a camera, but it can identify all sort of the waves, you know. And out of that waves, now we can look into it like 180 waves. Now that out of that three, now we can see the 180 points from the same flight. So the amount of data is going to be huge, and then we can create like so many correlations, so many data points, and so many informations out of it. It has been used in the agricultural industry for a long time, but it's not being used for the like infrastructure use for a longer period of time. So people just started using it for the infrastructure monitoring, and infrastructure monitoring becoming like a super hot topic. So if you can do that, uh, I think it's going to increase your value in every aspect. Whatever it really doesn't matter for whatever the career you want to build. And by the way, do you know why the infrastructure monitoring becomes so crucial nowadays? Nope, not because of that.
So
We are
for the
building it.
so for the energy sector.
Nope, not for the energy sector. The monitoring, there are lots of need for the monitoring. It's like if you go back 5 or 10 years, if you go 5 or 10 years back, you will not see that amount of demand to have like the monitoring what is needed now. Do you know why? Yes, very good, for the global warming, for the climate change. And for the because of the climate change, there is a significant changes in terms of the infrastructure. Do you know that? You guys are still 1 2, so you are still very fresh. So I don't think like you have like much understanding in the civil engineering now, but this is a really good time to talk about it too. So what happens is like in most of the infrastructure design, we need to use some data, right? Like let's say we wanted to build a levee system or embankment system for the flood protection. So for that, we need to do some kind of hydrologic analysis. We need to know is like how much rainfall is going to be, what is the like what sort of the water and all sort of things are coming in, right? But whenever we are doing all the design, we are using the historical data, meaning we are looking into the data. This is 2024. We will go back and see like whatever the data we had in the past 100 years, past 50 years, right? And then from there, we wanted to project it for the next 50 or 100 years. So we are using the data from the history to project the data in the future, right? Now, the problem is the data we are trying to use from the history is no longer valid to project the data for the future, right? So basically, what is happening is we are designing it and constructing our infrastructure system for a condition we don't know. And the thing is, we are having a situation is like we don't know what we don't know. So that's a big uncertainty and big risk is being integrated into the infrastructure design. So since we don't know what we don't know, we need to know what we don't know, right? So and that's why monitoring becomes like very crucial because we are trying to understand how the system is performing. So that's why, like, we are keep buying like all sort of the different sensors. We're investing on it. We have like a very big group working on that idea and coming up with different things. But I just want to finish it. I think I already have uh,
Yeah,
the
it's
time limit.
it's
Right?
already 18 minutes past 9. Yeah.
Already 18 minutes. Sorry, guys.
Yeah.
I don't follow the time. I just wanna show
So we
you one
started
more
late.
thing.
It's okay, sir. It's fine,
It's
sir.
okay. Okay. So, but I still have, I'm very sorry. I don't have it on my calendar. And I was talking about it, but I was not being allowed to capture that. Sorry. There's just one more thing, and then like how we can use it with like the LiDAR, ERI, or any sort of things, connecting it together, and then we can create a like we don't need to do any other things, any test or anything, but we are just able to use the data and uh, create a failure analysis of the whole thing. So there are like many different applications of it. So one of the application is like you when you are using the RTP and the thermal image, we can collect the data, and then from the data, we can do some kind of data analysis and create some models like that. Then there are like some other type of the things like we can also identify the hotspots of different locations if we have the image, you know. So and from that hotspot data, we can also make some other models and other things. That's from the thermal image. But in this case, I wanted to show you is like we can directly use it in the design. So for example, what we did is like we use the ERI data and it's a fail slope. So where is that fail slope? There is a fail slope and we use the ERI data. So from there, we use like some kind of like that changes in the soil surface. So there is a slope failure. After the failure, the surface looks like this. This is the original point, and this is how the failure looks like after failure. So from there, we get like different points, and out of it, we used where the points. Like from the resistividity, we got the points, and we connected together. We applied it here, and then we get a kind of recreated the failure surface. And I feel like this is really amazing because we did the whole thing is like in a week. Usually there is a big bottleneck in terms of the analysis and the design of the infrastructure. So for example, what happens is like the current workflow is if there is a slope failure or any other failure, people need to hire a contractor. They comes in, they do a boring, they collect the soil samples, they need to test the soil samples. It takes like a month just to get the data. And after getting that soil samples, they need to integrate it in the design. You need to run the analysis and so on. So just to get a email like a failure analysis and coming up with all sort of the data, it takes like a month, maybe a couple of months. Where if we use all these advanced tools, we can get it done in less than a week, you know. So in many cases, it's like you will see there is a washout of the levees. You will see like after a flood, like there are many media discussions in terms of like what to do and what are the things can be done. So this type of technologies is not only for the surveying, but it can be directly integrated in many applications, you know. And it can be also used for the evaluating the performance, looking into it like what are the things can be done and cannot be done. So it opens like many opportunities for the civil engineers. So Any of you can it's a career topic. It's not like a one lecture topic. Some of you may have it as a career. Just for your entire career, you can just keep doing that. You know. Anyway, any question? There is a huge demand of this type of work. That's what I'm saying. Because what is there enough? You don't need a funding. Honestly speaking, you just need a business because there is a demand means people will pay for it. Why you need funding?
Sir, if we start a business like that, we need to buy all the instruments for our business, right?
Yeah, so investor will give it because he will make money.
Yes, sir. And we need also need we professional engineers who can work with that instruments. Do we have that?
Well, the learning the equipment, it takes like a week. If you want to be a pro, you need to play with it for a month. That's
Yes,
it.
sir.
But in terms of the service, there is a huge need of that. There is a huge need of that. There is absolutely no question on that. You know. So what I think what may happen is like some white skinned people will go to Bangladesh and sell this technology and start something, and Bangladesh will buy it in a very expensive manner at maybe
So,
3 to 5 years down the line. So instead of that what can be done is like you guys can start doing that. So the cost will be 90 times cheaper than if someone from outside is going to Bangladesh and offering it, or maybe China will offer that. It's a very likely scenario in Bangladesh, but the political situation has changed, so may not be China. But historically, it used to be the China that usually go there and do it for the people. You know. I tried that. It didn't work. So it's anyway. There are like those are other discussions. But for you guys, I don't want it to discourage you. I think like any of you can start doing that. You just need like
sir,
some kind of support.
contractors are our main opposition, right? They don't want us
No,
to do these things
no.
because we can.
Contractor will love that.
We
Contractor will
love that.
love that. Yes, contractor will love that. Honestly speaking, the contractor will love that because what happens is like if there is a failure, the blame goes to the contractor. You know, so if you have the better data, it increase the reliability of the sensing, right? Because what
Yes, sir.
happens is like okay, this is the example I really wanted to give, and without giving this, I think this lecture will not be complete. So let's say someone had how many of you have a doctor in your family or
Sir,
knowing a
I have.
doctor?
Sir, I have
You
a
have
lot
it.
of doctor
Okay.
in my family.
Okay, you have a lot of doctor in your family. I also have a lot of doctor in my family.
Sir,
So what happens there is you go to, let's say someone has a cancer or tumor. Okay. The first thing, if you go to a doctor, what they will do? The first thing.
that they will examine or give us some tests.
Okay, what test do they give? Like if someone uh, they suspect someone has a cancer, what they will do?
Ultrasono
They
and
do a biopsy test.
Okay, biopsy first, they do the biopsy test or they do biopsy test later. First, they do something else. What they do?
no, sir. Sir, MRI
They
or
do.
ultrasound.
Okay, so they do MRI or ultrasound, right? That's
Yes, sir.
the starting point.
Yes,
So
sir.
if from the MRI they see something there is a problem, then what they will do? They will do the biopsy, right?
Yes, sir.
So, so biopsy is like what? You are putting a syringe, getting a samples, taking the samples out, and seeing it under the microscope. That's the biopsy, right?
Yes,
But
sir.
before doing that, you need to know like where to collect the samples.
Yeah,
So
where is the
from
problem? Where is the
vertical,
problem and cancer located?
where the problem in the cancer located, you need to do that anyway, right? So in civil engineering, most of the cases, what happens is like someone wanted to build a home, they hire a company, the company comes in and they just do it drilling and collect the samples, which is the biopsy, without knowing where the problem is, where to collect the samples.
So
So do you
what do
think
they
like it's
do
a good
with the
idea?
samples? No, sir. It's a waste of
They
money.
don't know what the problem is, right? So I
Yes,
used
sir.
to say is like the way the civil engineers are doing things, if the doctors keep doing, all of the people is gonna die,
Yes, sir. Sir,
right?
it's increasing a lot of cost, right? We are drilling the whole area without knowing, without just drilling a particular area for taking sample.
Exactly. Exactly. We don't know where to drill it, right?
Yes, sir.
So if we don't know where to drill it, then we will get bad data, no matter what, right? And you can see it like what the problem is, you see the variability within the locations. So within the locations, you see the variability, and from there you can make your call. Okay, so let's get the data from here. There we see some kind of variability here. So why don't we also get the data from here? This point maybe here from this point. Why there is a change? So we can also get the data from this point, right? So you can say it's like this is the interdistribution. So in this case, maybe one boring, there might be another boring here, maybe another boring here, like this. So what happens is like if you're building it and then later on there's a failure, there is any kind of things, the contractor can back it up because right now what happens is there is a blame game. The engineers, the designers blame it on the contractor blame it back on the designers, and so on. It's not good for not good for any party. You know, the best idea is like you spend money on the investigation more, you get a better image, you have a better understanding, and then you do a better design and better analysis like that. So the entire system can be used for those type of thing. Okay. Anyway, guys, I think I already took more than 30 minutes of your time. So if you want to keep talking, we will keep talking for another hour. So let's just stop it here.
All right. So, guys, if you have any question, just send it to me. If I get a chance, then I will definitely ask Dr. Khan about this. And thank you so much, Dr. Khan. It was a great session. So every one of us learned something new, something really helpful for us. So I really appreciate your time here.
Yes, sir.
Thanks
And
again.
I'm so sorry for being late. I don't
No,
know.
no, no. It's totally fine. Totally fine. No, no worries. Yeah.
It's
Okay.
okay. All right, guys. So I hope some of you will take it as a topic and work with it in the future.
Yeah. Hopefully. Yeah. Hopefully they will do it. Yeah. Uh,
Thank you.
thank you again, Dr. Khan. Good morning, and guys, good night.
Thanks. Good night, Ralph. Have a good sleep.
Thank you.
Thanks.
Bye bye.
Assalamualaikum, sir.
Assalamualaikum,
Alaikum
sir.
assalam.
Alaikum assalam.
Sir, Assalamu alaikum.
Alaikum assalam.